Section 13.2, Saturated Solutions and Solubility. As a solid solute begins to dissolve in a solvent, the concentration of solute particles in a solution increases, thus increasing the chances of the solute particles colliding with the surface of the solid. Because of such collision, the solute particles may become reattached to the solute. This process, which is the opposite of the solution process, is called crystallization. Thus, two opposing processes occur in a solution in contact with undissolved solute. This situation is represented in a chemical equation by using two half arrows. Solute plus solvent dissolves to a solution, and the solution crystallizes to a solute plus solvent. Figure 13.9, Dynamic Equilibrium in a Saturated Solution. In a solution which excess ionic solute is present, ions on the surface of the solute are continuously passing into the solution as hydrated species, while hydrated ions from the solution are deposited on the surface of the solute. At equilibrium in a saturated solution, the two processes occur at equal rates. When the rates of these opposing processes become equal, there is no further net increase in the amount of solute in a solution. A dynamic equilibrium is established similar to the one between evaporation and condensation discussed in section 11.5. A solution that is in equilibrium with an undissolved solute is saturated. Additional solute will not dissolve if added to a saturated solution. The amount of solute needed to form a saturated solution in a given quantity of solvent is known as the solubility of that solute. That is, the solubility is the maximum amount of solute that will dissolve in a given amount of solvent at a specified temperature, given that excess solute is present. For example, the solubility of sodium chloride in water at 0 degrees Celsius is 35.7 grams per 100 milliliters of water. This is the maximum amount of sodium chloride that can be dissolved in water to give a stable equilibrium solution at that temperature. If we dissolve less solute than that needed to form a saturated solution, the solution is unsaturated. Thus, a solution containing only 10 grams of sodium chloride per 100 milliliters of water at 0 Celsius is unsaturated because it has the capacity to dissolve more solute. Under suitable conditions, it is sometimes possible to form solutions that contain a greater amount of solute than is needed to form the saturated solution. Such solutions are called supersaturated. For example, considerably more sodium acetate can dissolve in water at high temperature than at low temperatures. When a saturated solution of sodium acetate is made at a high temperature and then slowly cooled, all of the solute may remain dissolved even though the solubility decreases as the temperature decreases. Because the solute in a supersaturated solution is present in a concentrated higher than the equilibrium concentration, supersaturated solutions are unstable. Supersaturated solutions result for much the same reason as are supercooled liquids. For crystallization to occur, the molecules or ions of solute must arrange themselves properly to form crystals. The addition of a small crystal of the solute, a seed crystal, provides a template for crystallization of that excess solute, leading to a saturated solution in contact with the excess solid.